Alright, and welcome back. In this video, we are going to be going through Chapter 9, Section 3, titled Arcs and Central Angles. And by the end of this video, we should be able to define and apply properties of arcs and central angles. So please have out your guide and notes, and let's begin. So over on the right-hand side of our screen, we do have a diagram. We have circle Q, and there are points on the circle A, X, B, and Y. Going over to the left-hand side, we have a couple definitions that we want to establish. So the first thing we're going to talk about is what's called a central angle. So an angle with its vertex at the center of a circle is a central angle. So angle YQA, angle AQB, and angle AQX are all central angles. Notice how Q is in the center of a circle, and Q is always our vertex of those angles. A, X, and B, as well as Y, are all on the circle. We also have what's called an arc. An unbroken part of a circle is an arc. So in circle Q, A and B, those 2 points determine 2 arcs. Arc AB is what we call a minor arc, and arc AYB is a major arc. Notice how in the minor arc we have 2 points included, A and B. In a major arc, it's AYB because major is bigger. If it helps you, minor is smaller, major is bigger. 2 letters is less than 3 letters. If the endpoints of an arc are on a diameter, then the arc is called a semicircle. So arc XAY and XBY, those 2 arcs are semicircles because Y and X are on the diameter. So we have a semicircle, a circle split in half. In order for us to find the measure of an arc, here is what we do. The measure of a minor arc is the measure of its central angle. So if the measure of arc AB is going to be 90 degrees because angle AQB has a measure of 90 degrees. The measure of any minor arc is always less than 180 degrees. The measure of a major arc is 360 degrees minus the measure of a minor arc. A circle has a total of 360 degrees, so we take 360 and take out the measure of the minor arc. So the measure of our major arc, AYB, is equal to 360, take away 90, so we get 270. And the measure of any major arc is always between 180 and 360. And naturally, the measure of a semicircle is 180 degrees. So the measure of our major arcs, XAY and XBY, are both going to be 180 degrees. With this in mind, please work on problems 1 through 4 on the guided notes and resume when you're ready to move forward. We also have what are called adjacent arcs. And adjacent arcs of a circle are arcs with exactly 1 point in common. So arc IJ is a minor arc, and minor arc JK are adjacent arcs. They both share the point of J on the actual arc. And we have what is now called the arc addition postulate. The measure of the arc formed by 2 adjacent arcs is the sum of the measures of those 2 arcs. So here we have an example over on the left-hand side of our screen. We're given in circle E, we're asked to find the measure of the angle or the arc named. So A is minor arc BC, B is angle 1, C is minor arc AC, and D is major arc ADB. So as we work through our solutions, minor arc BC is going to be the exact same measure as angle BEC, which means angle BEC we're given is 80 degrees, so the minor arc will also be 80 degrees. For B, the measure of angle 1 is going to be equal to the measure of our minor arc AB, which we are given is going to be 70 degrees. For C, we can use our arc addition postulate here. Minor arc AC is going to be equal to the sum of the measure of minor arc AB plus the measure of minor arc BC. We know that minor arc AB has a degrees of 70 and minor arc BC has a degree value of 80, so we add them together and get 150. And likewise, our major arc ADB is going to be 360 take away minor arc AB. So we end up with 360 minus 70, which gives us 290. With this in mind, please work on problems 5 through 19 on the guided notes and resume when you're ready to move forward. There we go. All right, and then lastly, we have what is called congruent arcs. So arcs in the same circle or congruent circles that have equal measures are going to be congruent. So minor arc AB is congruent to minor arc BC. Circle R is congruent to circle Q, so minor arc AB is congruent to minor arc XY. Minor arc AB is not congruent to minor arc ST because circle P is not congruent to circle Q. So long as we have congruent circles, we could potentially have congruent arcs. And likewise, if we have congruent arcs, we're going to have congruent circles. So this summarizes it up. In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So if angle 1 is congruent to angle 2, then minor arc JK is congruent to minor arc LM. And likewise, if minor arc JK is congruent to minor arc LM, then the angle 1 is going to be congruent to angle number 2. With this in mind, please work on problems 20 through 25 on the guided notes. Keep up the great work. Keep making yourself proud. Let us know if you have any questions, and we'll talk to you soon.